Hello everyone, my name is Sven Pistre and I am a PhD student in the group of Heiko von der Mosel at RWTH Aachen University here in Germany. My research, I'm interested in the plateau problem for a certain area functional arising in Finsler geometry. And for those of you who don't know the plateau problem, it goes as follows. You take any closed wire such as this or such as that, and then you dip this wire into soapy water, like this. And when you take it back out, you get this soap surface, this soap film. And now the question is this always possible? So given any arbitrary boundary wire, is there always a surface spanned by this wire? And the second question is, how regular is the surface or its parametrization? Now I'm going to consider a generalization of this problem to arbitrary codimensions, so not in three-dimensional space but in n-dimensional space, and I'm also looking at a different functional than the area functional. Now numerical examples for minimizers, they may look like this or that or this one over here, and you can compare this to the anapar-minimal surface on the other side, and you may see that they have these ridges which appear, which are kind of interesting. But nevertheless, in my lecture, I'm going to discuss higher regularity results. So these ridges, at least they're somewhat smooth, and I'm going to discuss these results in the framework of Cartan functionals, originally discussed by Stefan Hildebrand and Heiko von der Mosel in the early 2000s. All right, I hope I piqued your interest and you come and see my lecture videos. And if you want to have the slides, just follow this QR code and I'll see you real soon.
Hello, my name is Aaron Chow. I'm a PhD student in Columbia University. My current research interest is about geometric flow, and more specifically, Ricci flow. It is well known that Ricci flow has had profound impact on geometric analysis, and Ricci flow on closed manifolds has been a well-developed theory. On the other hand, there is not much known about its counterpart on manifolds with boundary. I will focus on the Ricci flow on manifolds with boundary in this talk. I will first talk about short-time existence and uniqueness of solution. Afterward, most importantly, I will address that many natural curvature conditions, such as PEG, PEG2, positive curvature operator, and positive scalar curvature, are preserved along the flows under suitable assumptions on the boundary.
Hello. I'm Demetre Kazaras. I'm a postdoc at Duke University, and I'd like to introduce myself. So recently I've been, and in general, I'm interested in ideas surrounding differential topology and general relativity and most anything having to do with scalar curvature. Spinners, minimal surfaces, things like that. So what I've been working on over the last year and what I'll be talking about is new proofs of, studying mass and general relativity in dimension 3. So the positive mass theorem has a lot of history, and in dimension 3 you have the intersection of a lot of interesting ideas. Going back to the original proof of the positive mass theorem, all these notions I'll introduce. Due to Shane and Yao using minimal surfaces, and then by Witten using spinners and all sorts of other interesting and invigorating ideas like inverse mean curvature flow and other sorts of flows and ideas that all prove the positive mass theorem. And I'd like to talk about some work that I've been doing in this direction that is analyzes a new type of object, basically some kind of special one form. And so, there are connections, rigorous connections you can make to what they have to do with minimal services, and rigorous connections you can make about how they relate to spinors and how Witten proves the theorem. So I look forward to sharing these ideas with you, and I hope to see you there. Thank you very much to the organizers for Hojo Lee for setting this all up and having such a engaging and interesting vision for how this conference will go. All right, nice to meet you.
Hi, my name is Martin Lesourd. I'm a postdoc at the Black Hole Initiative in Harvard University under Professor S.T. Chow. I'll be talking about scalar curvature on non-compact manifolds, and in particular the question of which manifolds admit a metric of positive scalar curvature. This is an old question. Fundamental results were proved by Shane Yao in '79 and Gromov-Lawson throughout the '80s. There are many questions that remain, and various new techniques and ideas have been introduced by Gromov, once in a very long and profound survey paper in '96, and recently, since about 2014, a flurry of papers by Gromov. Recently, Chow and Gromov resolved the aspherical conjecture, namely closed aspherical manifolds do not admit a metric of positive scalar curvature, which is a conjecture that was known for a while. They resolved this in the case that the manifold is 4-dimensional or 5-dimensional. And I should mention that, of course, in 2 and 3 dimensions, the question of which manifolds admit, at least for the closed case, a metric of positive scalar curvature is fully resolved by the work of Perelman and by classic results in 2 dimensions. Our work with Ryan and Yao was inspired by some old ideas and results of Shane Yao, where we tried to generalize this to the non-compact setting. In the end, perhaps the main theorem is that a certain type of manifold, which we consider, or which we call Shane Yao-Schick, connects some with an arbitrary open non-compact manifold, doesn't admit a complete metric of positive scalar curvature if this arbitrary open manifold satisfies some certain conditions. I'll talk a little bit about the methods, the proofs, and some of the other methods and proofs introduced and exploited by Chow and Gromov, so-called mu bubbles. I'll compare and contrast these two methods, and I'll describe some of the questions and some of the main problems that remain.
Hi everyone, my name is Francesca Salvatore and I am a PhD student in Turin. First of all, I want to thank Jolie for the great opportunity of giving this talk. My research interests revolve around differential geometry. In particular, I'm very interested in the study of special geometric structures in dimensions 6 and 7. In my talk, I will present some recent results in collaboration with Anna Fino and Alberto Raffero on closed G2 structures and solitons of the Laplacian flow on 7-dimensional solvable Lie groups with non-trivial center. I hope you will enjoy my talk. Bye!
Hello everyone, I'm Fabio Paradiso. I'm currently a PhD student at the University of Turin. I work in the field of differential geometry. To be more precise, I'm studying generalized geometry, special Hermitian structures, and geometric flows, especially in the context of Lie groups. In my talk, I will be speaking about some recent results I have obtained in collaboration with my advisor, Anna Fino, regarding balanced Hermitian structures on almost abelian Lie groups and their behavior under some important geometric flows in balanced geometry. I also want to thank the organizers for the great opportunity of participating in these nice events, and I hope to see you at the Q&A session after watching my talk, and I hope you have a great day. Bye!
Well, hello everyone. My name is Pablo Mira and I'm a professor of mathematics at the Polytechnic University of Cartagena, which is in Spain, in the southeast part of Spain. And I am also a member of the research group on surface theory and geometric PDEs of the University of Granada, which is also in Spain. I want to thank Hojo for organizing this Geometric Analysis Festival and of course for counting on me to deliver one of these mini courses of the conference. I hope that the next meeting that Hojo organizes will be under better circumstances because I am really looking forward to travel again to Korea. So in this festival, I am going to present a series of lectures about the uniqueness problem for constant mean curvature spheres. So what is this? Take for instance a Riemannian three-manifold, which will be viewed as our ambient space and some prescribed real number. Then we want to find all two-dimensional spheres immersed in our ambient manifold that have constant mean curvature given by the value that we have prescribed. So this is a classical problem. Some things are known about it and many other open questions remain. And in these lectures, we will travel from the most basic uniqueness theorems that are known, for instance, Hopf's classical soap bubble theorem for constant mean curvature spheres in Euclidean free space, to the most updated general results that are currently available on the problem. We will sometimes also bifurcate from constant mean curvature theory and consider uniqueness problems for immersed spheres in other related geometric settings. And also in the final lecture, I will present a large number of open problems and conjectures related to this uniqueness theory. So if you are interested in uniqueness theory for constant mean curvature spheres, you are very welcome to join the talks. I hope they will be fun. So that's it. Hasta pronto.